Hello, everybody. Thank you for joining us today. My name is Emily Kuda, and I'm Percona Senior Manager of Marketing Programs. We're going to get started in just a moment. First, I just want to conduct a little bit of light housekeeping. Can you raise your hand using the hand icon located in the control panel to let me know that you can hear me okay? Great. Okay. Next, during this webinar, you will be on mute. If you have any questions during the discussion, please enter them in the control panel. At the end of the webinar, we're going to take time to answer as many questions as we can. In addition, a recording of this webinar will be made available to everyone within 48 hours or less, along with the slides. So with that said, I'd like to thank you for attending today's webinar. We're going to be talking about enterprise-grade PostgreSQL. Built on open source tools presented by Percona's Postgres support technical lead Avi, senior support engineer Fernando, and senior support engineer Jobin. So with that said, I'm going to turn the floor over to Avi.
Hello, everybody. Good morning, good evening, good afternoon. I know many people will be joining from various locations. So I'm Avi, and as Emily already mentioned, Jobin and Fernando are with us here today too. And we'll be talking about a lot of stuff today. And we are here to demo you the various options that you have to build an enterprise-grade Postgres server using open source tools, right? So why is this webinar? Why do we need to talk about this today, right? So let's go ahead and discuss that. So let's start with the usual myths that we see or that we hear when we are dealing with an open source product, like an open source database software, especially like Postgres, right? When we are kind of migrating away from a commercial database software, which is with a lot of enterprise-rich features as promoted, marketed, right? We hear a lot of things that open source products doesn't really get you this, doesn't get you that. You need to buy some license or support, etc., and all that, right? So let's hear a few of those myths. We always hear like security is not free; it comes with a cost. You need to pay some license or get another subscription in order to get better security. And I cannot take full backups, which is good for point-in-time recovery. I may need to go for an enterprise level feature that gives me a backup option. And sometimes we also hear like, oh, with open source products, you may not be able to get a high availability. Again, like you cannot build replicas, or you cannot do an automatic failover. You cannot really achieve an always on if it's purely open source. And even if you could, it's not scalable. You always need to vertically upgrade your hardware, and you cannot really make it more scalable. And at the end, DBAs could even feel like, I really do not have enough database maintenance options on open source softwares like I could do with the enterprise grade softwares or the commercial products, right? So consider this as myths, right? So what is an enterprise grade Postgres in our definition, right? And it's definitely not limited to the list here, right? Especially talking about security, right? Like encryption. Can my data in motion be encrypted? And data at rest, can it be encrypted with an open source product like Postgres? At the same time, can I really manage my users well with perfect access control list, like privileges using roles and user management? Can I tune my database system, right? All these are kind of an enterprise grade feature, right? Even connection pooling, load balancing, so that you can really balance the traffic between your master and even replicas or slaves or standbys, whatever we call, right? So that we could use the computing power of all the hardwares in the infrastructure, especially in a database cluster. And can I audit and log some activity of my database to see what really happened at what point of time? At the same time, if somebody has done something wrong, can I see that? Can I audit it? Monitoring, replication for high availability, automatic failover, backup strategy, and routine database maintenance tasks, partitioning, bug fixes, security vulnerabilities, patches. All these can be considered as an enterprise grade feature. And at the same time, it may not be limited to just the list here, right? We just put a basic list here. So before we starting the demo, when we announced the webinar, we did post a lot of blog posts on various topics. So we divided the blog post into 7 topics, right? Like, and even this webinar will be divided into 7 topics, and we'll be talking about each of these today. The first one will be securing your PostgreSQL database cluster, high availability, backup strategy, scaling Postgres using connection pools and load balancers, extensions available for DBAs, developers, and the other business requirements, detailed logging, and monitoring, right? So let's start with security. And I'm going to demo, the setup that we have done for you. So we have done this setup on AWS as well as on our local machines, right? So let's talk about security. The security part can be divided into like 3 categories, I could say: authentication, authorization, accounting, and auditing. So let's start with authentication. If you're a MySQL user, when you are creating users and giving an access to a user to connect from a remote host, you could always say like create user at an IP address or a whitelisted range of IP, so that the user can only connect from that IP. However, in Postgres, right, you could actually go ahead and whitelist such IPs in your host-based authentication file, which is by default located in the database directory, in the data directory. So you can use a combination of 5 aspects here, like if it's from a remote host, what IP address using which user, to which database is the connection accepted. So if these categories matches, only then a user can connect to the database server. For example, here I actually say that any user, right, all users from all databases from this IP address can connect to this database server, but with password authentication, which is the MD5 method. Trust without password authentication. So I have this host-based authentication file that really says what user or which user from which IP address to which database can actually connect. And you can also say reject if you really want to restrict connections from a specific IP, right? So it's highly customizable. And you can also go ahead and say that the connections from a specific IP or all the IPs should be encrypted over wire using SSL. You should have got OpenSSL, right? And likewise, Postgres does allow you to use Kerberos SSL, like client certificate authentication, Scram SHA 256, PAM-LDAP a lot, right? Talking about user management now, while talking about authorization. Postgres does allow you to create roles and assign privileges to the roles so that you can actually assign roles to a user. Why should we do that? For example, let's say we have 2 schemas in our database, like Scott and Tiger. Now, you may have application accounts which write and read, and at the same time, you may have developers, you may have other users, business users, who might just need read access or write access to specific schemas, right? Managing such users may be difficult because if you really have to, without roles, it'll be difficult because you have to specifically grant, select, insert, update, or any other privileges to each user on each table separately. Instead, we can have roles, right? Like a Scott underscore read only role, for example, and a Tiger underscore read only role, right? And at the same time, a read write role. Just create the roles and assign the insert, update, delete, or the select privileges on the schema to the role rather. And you can assign this role to the user that you create in your database. So, right? For example, perk user is not an application user. It's just a, a developer, let's say, right? So he can just get a read access by directly giving only read-only roles. At the same time, the application user may need a read-write access. So you just go ahead and give a read-write role. So this way, like, you can read through your environment and understand what kind of privileges you really need to give to users and have your roles created and just assign those roles. At the same time, Postgres does allow you to enable row level security. That means I would not be able to see the rows or the records in a table that I should not be looking at, right? For example, you can go ahead and enable such row level security where a manager would only be able to view the records, or the salary details of his own reportees, but not any other manager's reportees, right? So you can enable row level security. And as I've showed some time back, you can use encryption of data over wire using SSL. For example, like, I would go ahead and connect, to the, so here's my application server, and I'm connecting to a database server through HA proxy port. I'll talk about that a little later. And I could see that the connection is encrypted using SSL over wire, right? At the same time, you can go ahead and log all the activity through various logging parameters. I know few of you might have already looked at our, the recent blog post on detailed logging, right? So if not, the links are already in this slide, and you should be able to go through and refer to the blog and understand what are the various parameters that could really help you log and audit. And at the same time, we always see nice bug fixes, and as well as patches being released every quarter almost by the Postgres community. And you may subscribe to a blog post if you really need to know that if there is any security vulnerability that was noticed. And Postgres community does take the security bug fixes very seriously. Just subscribe to a blog post to hear more about any other security vulnerability that got fixed, right? And now, backup strategy, another important aspect while building an open source, enterprise grade solution using open source tools, right? Postgres does allow you to perform an online consistent backup that's good for point in time recovery without any extra license, right? I mean, it's available by default with the vanilla or the community Postgres PG based backup. That's a nice tool that can run from a master or even a slave or a standby, right? Like, you can take a full backup of your Postgres cluster, and you can enable archiving so that you can achieve a perfect backup strategy that allows you to recover up to any point of time in the past. At the same time, Postgres does allow you to configure logical backups using pgdump and pgrestore, just like expdp and impdp in Oracle, or MySQL dump in MySQL, right? So you have all the variety of backup features available with Postgres by default. At the same time, there were several umbrella projects that are developed and available for us for free, and really beautiful projects that are active, highly active, and very active community, like, who responds to your questions real quick, right? One among them is PG Backrest. Like, let's say you have terabytes of database cluster and you want to use multiple CPUs, like parallel threads, in order to go ahead and back up your database. And at the same time, you want to stream it directly to cloud, right? And perform incremental differential backups. You may use PG Backrest. Likewise, Barman is another backup and recovery manager tool developed by Second Quadrant. WallG, it was Wally earlier, where it can stream the backups directly to any cloud, And now Volgy is really, like Wally was in Python. Volgy is being developed in Golang, and it's already active. More and more vendors are being added, cloud vendors are being added so that you can push to any cloud. So there are nice, decent projects that are available for you to really get all the speed or unique requirements that you have for your environment. And we will be creating blog posts on all these projects soon so that you can actually see how to work on them and what you could do to get there. So the next aspect that we want to talk about is connection pooling and load balancer. So before we're talking about that, and I would want to say that like we have already built a demo setup with all the aspects that we are talking about today. Like I just shared the screen some time back showing the security aspect, right? Like we have 2 application servers and 3 database servers that would be displaying in this demo now. And so yeah, anyways, now, so we'll be talking about connection pooling and load balancing, and I would let Fernando, talk about connection pooling and load balancing and explain us about it.
So hello everyone, Fernando here. And before we start talking about connection pooling, I just wanted to go back really quick to the archiving functionality in Postgres. So I have most of my SQL background, and I can't really stress how interesting this built-in archiving feature from Postgres is, and how enterprise grade it actually is out of the box, right? So this is for sure a very, very interesting functionality, which really saves people from a lot of trouble along the line. So the connection pooling aspect of Postgres is kind of a particular one. We need the main spot. Can you go back to that connection pooling slide, Avi, please? So the main, yeah, that one. The main reason that this is different from so many other database technologies is the fact that Postgres is process-based, which means every new connection that comes to the Postgres and it is actually accepted, it triggers a fork of the main process, of the main operating system process. And this is quite an expensive operation, in fact, if we compare to some more lightweight ways of doing that, like every other thread-based database such as MySQL. In this particular aspect, there is of course a lot of advantages, and it's really an implementation option. The fact that you have so much visibility at the OS level from everything that works in Postgres is for sure something that helps DBAs in troubleshooting a lot of the problem. But the fact that every new connection triggers a fork in the main process from Postgres, and the fact this might be expensive, lead us to look at connection pooling a little bit with more kind of focus. Right, and this is not always the case, and this is something we should stress here. So it really depends on the nature of the workload, on how many connections are actually arriving every second. Because if your workload is composed of a bunch of really short connections that arrive all the time and forces the Postgres to just fork and create a new child process, then a connection pooler has an important kind of element to your setup, but it's not always the case. So if you do have this workload that is composed of many small connections that sometimes for a single transaction, looking at a connection pooler is a way of scaling your setup if the need is for this. So there is actually two kinds of connection pooling mostly. One that is attached to the application itself, which will be kind of closer to the programming language you use or the framework, development framework you use. So Those are kind of what we call the native application connection poolers. And we stated here it is preferred because it kind of integrates much better with most of the applications. In a sense, it speaks the programming language much better and a little bit less of Postgres itself. And the external connection poolers, since the one we have used in our setup, like a PG Bouncer, those are much more kind of integrated to the database itself, in this case, Postgres. So whether you are going to use a connection pooler at all, or you are going to use an active application connection pooler or an external connection pooler, it depends on your reality, right? We are taking this here, the step of presenting a more generic setup, and for this case, we choose to have a connection pooler that is an external one. And how this works is like it kind of creates a series, a number of connection directly to the database, and keep those connections open all the time between the connection pooler and the database. So it actually serves as an intermediator between the application server and the database. So while the connections between the connection pooler and the database remain open, the connection pooler, it kind of manages all incoming requests from the applications and redirects those to the connection pooler using one of the active connections it has established. So that is to kind of take out of this task from the database itself. And then we have the load balancer, which is another piece of this puzzle and has kind of a complementary function here. And we will talk more about that in the high availability part, but what a AJ proxy setup like the one we have here, it serves two functionalities. One, it is to redirect writes to the master server and distribute reads to all the replicas we have using some sort of algorithm for this. And the other is, of course, to play a part in the high availability scenario. So I will hand over to Avi for him to show us this in practice a little bit more.
Right. Okay. So thank you, Fernando. And so on our application servers, we have got HA proxy as well as PG Bouncer installed. So if you could quickly look at the configuration file of PG Bouncer here, right? We have, I'll not go through the entire configuration in the interest of time, but I'll just talk about the two databases that we have listed here in the connection pooler. As Fernando said, when a connection to this database, let's say master, is established, it'll create a pool of connections and keep those connections persistent so that they can be reused, right? And PG Bouncer understands the protocol of Postgres and really does the required cleanup, and you have enough settings to really make it work the best. Now you could see that there are two alias names or two database names. Master, it's connecting to the localhost port 5002. So both are actually connecting to the HA proxy ports, right? So this way I can distribute my writes and reads. Let's say I would like to let some of my application modules, a few of my application modules, establish connections to master because they always write. And I do have a few application modules that just does read or reporting like stuff, right? So I could let them be redirected to the slave database of PG Bouncer. And now, just look at this for now, right? So we'll go to the HA proxy configuration file and see that here you could see the 5002, like what it is actually doing is it's calling the Percona API and searching for the role master. And whichever is the master, it's reading the HTTP header and redirecting the connection to the master, right? And at the same time, whatever database server has got a role replica, the connections to slave database are actually redirected to the replicas only, right? So that is why if you could see here, like we have written a simple, Python script here that actually shows you where the read connections are going to, right? Like you could just see here, like it's connecting to the HA proxy port, nothing much. And if I just run this, you could see that the connections are being established to, this is one of the slaves, and I'll try killing it and reconnecting. So it is switching between both the slaves now, right? So this way you can use different algorithms within HA proxy to distribute your workload appropriately, right? So now talking about PG bouncer. Now I would go ahead and connect to the master database, right? And if I go ahead and check the IP address, this is the IP of the master. And at the same time, if I connect to a slave database on PG Bouncer, this port is PG Bouncer's port, right? It's connecting to a slave. So this way, I can go ahead and distribute my application traffic to a write or read, and it's seamless to the application. The reason why it's seamless to the application is because we are relying on the HA proxy to decide where the write and read connections should go to. And HA proxy is talking to Percona API to understand what is a master or a slave. So now we'll see more about that in the next slide, while Jobin talks about the high availability stuff that we have used here, right? So high availability and automatic failover. So I'll quickly introduce the high availability part and hand it over to Jobin to talk more about the high availability feature that we used. So the first step towards achieving HA with any database cluster is replication. And Postgres does offer excellent replication methods. And the preferred one being streaming replication, and then we have a logical replication. Streaming replication does allow you to set up synchronous, asynchronous, cascaded, though a few of, most of the features are possible with logical replication. Streaming is preferred replication method for high availability. And there are several open source contributions done in order to achieve automatic failover, and all of these are being used in production, right? One of them, you see Percona, Rep Manager, Stolon, and many more other contributions. And this list is not just limited to what you see here. For this enterprise grade setup that we are going to demo you today, we have used Percona. And I would let Jobin talk about Percona and how it helps us.
Hi everyone, Jobin here. Thank you for attending. Yeah, so let me give you an overview of this Percona. So as Avinash already talked, there are n number of HA solutions, and it is not something came up suddenly. So the community was trying to design a better way of doing things always. And we have n number of solutions on the way. And all these solutions, today's solutions, uses the built-in features of Postgres, especially the replication and ability to rewind a lost master and ability to rejoin that master back to the cluster. So, and when we talk about the high availability, there are n number of challenges we need to address to achieve higher number of availability. Say you might have heard availability of 3 nines, 4 nines, and up to 9 nines or 11 nines. So when we look at features for more and more high availability than the previous generations, we have to solve many of the problems which the previous generation didn't solve. So just like Postgres, there are n number of open source projects happening around the world, and Postgres is leveraging those capabilities to achieve this high availability solution. So Percona is one of them. And just like when we say leveraging the features of open source, just like Linux provides a lot of high availability features like distributed block replicated devices. So etcd is a implementation of raft algorithm to solve the consensus problem. Okay, So when we talk about high availability, we generally think about losing our master database, the most important database. So the quick solution is a slave takeover. But there are n number of questions there. So which slave, and how I'll make sure that there is no two slaves take over, and how I can be sure that the master is actually down, um, um, or the old master is sitting somewhere in the corner in an isolated place and doing still some processing. How to make sure that it is really dead. So there are n number of questions to be answered. So etcd is gives a solution in terms of raft algorithm, which will give us the consensus. Okay, who is the right master? So just like a democracy, yeah, the nodes in the cluster need to go for voting. So, and it is a repeated process. It's not one-time activity. For every action, there should be a consensus. So the etcd works, or in short, we call HCD. HCD works like a distributed store. So the master says, if a node want to be master, he need to update the etcd store as I am the master. So, but he cannot just do that unless he gets the vote. So it need to go for an election. So the raft algorithm makes sure that there is a clear-cut victory for one of the master. So that's what yeah, the Percona is making sure that. So and the other challenge, the existence of more than one master in a cluster, that is a big disaster. So if you think about the high availability solution like Oracle RAC, so they have the mechanism in place to address such a split brain situation. So they call node eviction. So that is a built-in feature of such a highly popular solutions. So what they do is they'll make sure that if a master, existing master, is not re-elected, it will be down for sure. It is no longer processing any more data, so that we can have a new master taking over the things. And so there is no split of data or the leadership. So in HCD, in this Percona, we are using the Linux feature of Watchdog. So to achieve that split brain situation. And on the top of this entire cluster, we have HA proxy, which Avinash and Fernando already talked about, which will be doing the connection routing. So HA proxy will route, it maintains a routing table internally, and it checks with the Percona to update that routing table. And when a connection comes, based on the connection request, it routes the connection to the master or slave. That's the overall idea about the Percona setup. So we are going to see more in detail. Yeah. Over to Avinash.
Thank you, Jobin. So now, as already Jobin explained about Percona, we will show you, like we'll do a push failover, a manual failover, and show you that how simple it is to really manage a failover. For example, in your environments, especially in several organizations, we do disaster recovery validations, every 6 months, for some compliances. And we always try to switch over to standby and see if all the applications are really working well after switchover, and again fail back or switch back, right? So that kind of testing always keeps happening in majority of the environments, and that's not really difficult. So you could just see, right, like right now PG0 is the master, okay, and PG1 and PG2 are followers or slaves or standbys to PG0. Currently the lag is 0 megabytes, and the PG0 is the leader. I would go ahead and quickly perform a failover. Okay, as it's a push failover, I have an option to choose what would be my preferred master. I would say PG1, right? So it's asking me a confirmation whether I want to demote the current master PG0, and I would say yes, please do that. It's a planned failover. right? Now, the new master is PG1, right? And PG0, PG2 will be restarted automatically by Petroni so that they start following PG1 as slaves or replicas or standbys, right? So now you could see PG1 has become the master. So this way, failover or failback or switchback is very easy. So you have Petroni-like open source solutions available or all the time to really manage automatic failover in Postgres really well. And yeah, so next we will talk about extensions in Postgres. Why extensions? Firstly, so far we have seen already Postgres is feature rich by default and completely community driven. Postgres also has given us the capability of adding extensions. So let's say you have a unique requirement for your environment and like for example, a database administrator says, okay, now I need to do something like a DBMS redefinition that Oracle gives me to rebuild a table online, right? Or a PT online schema change. Can I do that with Postgres? Okay, so you have, I mean, like all these requirements, like if you would have got one requirement, there is always a chance that somebody else would have already got that requirement in the open source community, right? And people have really contributed to a lot of extensions that work with Postgres and are available for free. Of course, they're all open source, right? So that actually makes our lives easy. So Postgres has, I mean, this list is really not limited to this one here because there are hundreds of extensions available, right? So a few of them that we are going to talk about maybe are PG stat statements, PG repack, PL profiler, or a phase where if you want to port your applications on Oracle to Postgres easily so that it can use the Oracle specific functions on Postgres, you can use the extension or a phase. Postgres does have several language extensions, foreign data wrappers so that you can talk to a remote homogeneous or heterogeneous database, like be it Postgres or MySQL or a remote Mongo. You have foreign data wrappers. And one of the others is with Percona anyways, but yeah, anyways, so Postgres does allow you to add extensions. So let me demo something very which could actually find interesting, right? So we have promoted our earlier slave PG1 as a master now to a master. So now it can accept writes, right? So if I do a select PG underscore is underscore in underscore recovery, it's false. It's not in recovery. It's a slave, right? So what I would do now is I'll go ahead and look at this PG bench branches table. I could see that there are 0 dead tuples and live tuples since the last analyze. I would go ahead and run an update of this on this table, and set BID to BID like it's one of the columns. And now I see that there are 10 dead tuples, right? Likewise, the number of dead tuples have really gone high, and you are maybe running vacuum to clean up that space, but that space is available for reuse after vacuum, but the space is not actually reclaimed to the disk. It's just available for reuse. It's added to the free space map. Now, in order to really, like, let's say you perform a huge purging of one of the tables, right? Like due to some kind of data archiving and retention strategies, you purge a huge amount of data from a table. You might want to rebuild that table so that you can go ahead and reclaim that space and let that table perform faster. You have a PG repack extension, right? That does an online repack, like online reorg of a table, right? So even Postgres does allow you to build tables online, rebuild online tables online, right? Now I see that the dead tuples are 0, and the table has actually shrinked its space. I mean, earlier if it would have taken a gig, now it might have taken something less than that when it rebuilds the table, and it's online. So you have several such extensions that are available to make your life easy, right? A few of the extensions are created here. So if in case you're looking for some feature and if you want to know if that's available in some extension or something, just feel free to get back to us or respond to us on our blog post, or or reach out to us to hear if in case something that you're looking for is available already, right? And detailed logging and analyzer. Postgres does allow you to enable detailed logging of activity, and it allows you to customize your logging too, right? You can either log DMLs, or you can log just DDLs, or you can log everything that's running for more than a certain time, like logmin duration statement. Here I say log every statement that's running for more than 1 second. And at the same time, let's say you're running a stored procedure and you have got several nested function calls and SQLs in that. You can log them too using auto explain, right? So Postgres does allow you to log all the activity, and as it's logging all such information to a log file, either in CSV or text, right, to the file system, to the OS, you have log analyzer tools like pgbadger, and Percona's PMM is under development, and you would see that too shortly, which does a great query analytics, right? So we'll view one of the pgbadger reports, right? So here you could see a pgbadger report, which is again available for free. It's generated out of the log file that is built out of all the SQLs that are generated for all the SQLs that are running for more than logmin duration statement here, right? So you could see like top slowest individual queries, right? And at the same time, you can see top time consuming queries, what is a minimum average duration, with some examples, which gives away the bind variable values, right? This helps you in tuning your Postgres database server. So pgbadger is again available for free. So you can do detail logging, you can do log analyzing, everything with what is already available. And continuing to the next part, monitoring. Again, another important aspect. One of the enterprise-rich features that everybody would be looking for is, can I look at the history, analyze the history, and say what could happen? Can I be predictive, right? Gone are the days where we need to be reactive and proactive. Now it's being more predictive. So in order to be predictive and see what's happening, we may want to really analyze the history. And there are several open source tools that are available for PostgreSQL to do that, right? However, we want to show you the UI that's generated out of PMM, right? So you get this Postgres overview dashboard, and it's still extensively being developed. You'll see more and more. So you can go back to a certain point of time and say, like, look at past 2 days, look at past 7 days, right? And you see PostgreSQL connections, active connections, tuples, tuple activity, transactions, and checkpoints, logs, conflicts. So this way you actually understand, like, let's say cache hit ratio. Okay, looking at all these metrics, you can understand if my Postgres server is really behaving well, or if there is a sudden spike or a sudden decline, or what's happening. Should I right size my database? Like, should I upgrade it or downgrade the server? Because majority of the environments, where I worked, I've even seen like they go ahead and overgive the resources. Like, if the server does not really need 24 CPUs, if it just needs 4 CPUs, we allocate 24 CPUs, right? That's a place where you need to do right sizing. And in order to do that, you need to have such metrics available, right? So you can always try PMM that helps you with or even all these other open source tools, whichever really works for your environment. Go ahead and build them. So you can even achieve monitoring, and even few of the tools does allow you to achieve alerting, especially Nagios, right? So you can use them, and you can even get this feature done. So with Postgres, just with the community Postgres, the open source, you can go ahead and build detailed logging, build monitoring, build nice secure database server, highly available with automatic failover that's seamless to the application. At the same time, even scale it using connection poolers, load balancers, so that you are really using the computing power of every server, right? So Postgres does allow you to build all that. You just need to know what combination to use and what combination works for your environment, and that's it, right? And this is how the final architecture of our demo looks like. So we have demonstrated you the Percona cluster. We have done a failover from one master to another slave, and we have done, we have also showed you how PG Bouncer is connecting, like writes and read connections to appropriate servers. We have shown how HA proxy is redirecting to the connections to a master or slave appropriately. And we also have got PMM server, and we are also pushing our archives and backups to our backup server, right? So this is the demo that we discussed, but this may not be your environment too. I mean, this may work, okay, and what works and what does not work really need to happen by understanding and reading through your environment, right? So with this, I would also like to say that we have a Percona Live PostgreSQL track on November 5th until 7th, and you can just get onto this website and you can see more details, and maybe we'll see you there. And now I'll open for questions, and myself, Fernando Jobin, are here to answer your questions, if any.
Thank you so much for that, Avi. All right, at this time, we're going to take some time to go through some questions. Go ahead and enter them now into the questions panel. Our first question is, how to prevent super user account to access raw data in Postgres?
Okay, can I see that question? Sorry. Okay, I see it now. Yeah, 1 second. Show questions. Okay, Emily, can you repeat that question? I'm sorry.
Sure. How to prevent super user account to access raw data in Postgres?
So if you want to do that to super user, firstly, that may be a question. If when you really give super user accounts to your application accounts, right? One thing that you always need to know is, or we need to be very clear of, is we need to avoid using super user at every places, like in the application accounts or for our routine developer activities. We need to have specific user accounts with appropriate set of privileges that could not really do all the super user kind of activities. But rather, you need a super user all the time, right? And you never want to restrict a super user from doing some activity that really needs to happen. So instead of granting a super user to a user who has to do super user like activities, I would suggest you to look at security definer, and through that you may achieve super user like features most of the time. But I would rather oppose you granting super user, and again, to the super user role, restricting the privileges is not possible. So look at the security definer ones that's available.
So Avi, and I'm right to say that you really can't hide that raw data from a super user, right? Unless you really kind of store it encrypted, you can't really avoid a super user to use that. What Postgres does really well is this segregation of privileges into different roles. So it's possible for you to provide different privileges to different users and avoid kind of letting the super user privilege being shared by many. That's how I would do it.
Absolutely.
Yeah, I just want to add, so like Avinash already said, the user segregation and giving the right user right privilege is very important. and like Fernando mentioned, the encryption part. So the theoretically, the super user can see any data, but the data should not be something meaningful for him. Say, suppose I'm a database user, and I want to store some data which is no way useful for others. So the option for me is to encrypt that data and store in the database. So the Postgres supports encryption. The PG crypto module, like Avinash talked about the extensions. PG crypto is a extension for Postgres, using which you can encrypt the data which is stored in the database. So the application user can insert some data which is only visible for a format for that application user. But if that, since that key is not there with the super user may see a encrypted data. And the other part of super user, when we talk about super user, is not only the Postgres super user. Hello.
Sorry about that. Jobin, you.
Cutting a little bit.
Yeah.
Yeah. Just to complete.
So,
just remember that you know, you have ways to make it more difficult for a super user to have access to the data, and you also has this kind of super raw level security feature into Postgres. Just remember that comes with a price in terms of performance, because it's really more work for Postgres to handle, for example, the decryption part, and also the when it needs to actually verify who has access to a given role, for example.
Thank you. All right. Our next question is, can you talk a little bit about encryption at rest for Postgres, PCI or PLL applications from Percona?
Yeah, I think Jobin just now mentioned about one of the extensions that's available for you to achieve encryption of data at rest using PG crypto. So we would suggest you to look into that. And we have, I mean, if I'm not wrong, there was a blog post that was already published sometime back from us on security. Just a second. Let me, yeah, so I mean, you can explore PG crypto module more, I would say, right? And that should help you out. So yeah, you can get to the securing PostgreSQL blog post once and read through it. And if you don't see that there, do respond, and we will talk about PG crypto in our maybe another blog. Yeah.
Thank you. Question regarding Percona. Can we select in settings to not failover automatically and only use Percona for manual failover failback?
Yes, I mean, Percona does allow you to do that, but the reason why we set up Percona is, of course, yeah, I understand. Like somebody may want to do a controlled push failover, so that's why this question is raised. So yeah, it's customizable. I would let Jobin add more if you think there is any other case, Jobin. Okay, I don't hear from Jobin. So that's customizable. Yes, the answer is yes for that. Yeah.
Yeah. Sorry. Yeah. Yeah. It's customizable. Yeah.
Great. Our next question is, can you let me know between the two scaling solutions which one is better, PG Bouncer or PG Pool 2?
Right. That's a very interesting question, right? PG Bouncer and PG Pool, that's always, yeah. PG Bouncer is considered to be a lightweight connection pooler if you really want to only look at the connection pooling part. And PG pool, more than the connection pooler part, it's actually used for high availability too, right? For example, you want to go ahead and do an automatic failover, or at the same time, let's say you want, a logic which is like proxy SQL in MySQL. For example, let's say it has to parse the SQL and understand if that's a read or a write, and redirect that SQL to an appropriate server. For example, write connections should be always sent to master, and read connections should be balanced between a master and another slave. PG pool can do that, right? So comparing it, right? PG bouncer is of course known for a lightweight connection pooling. As well, PG pool, you may want to really do some benchmark depending on the requirement that you have after some testing in your environment, and then put it. But definitely we will come up with some benchmark in the future which shows maybe PG bouncer versus PG pool just for the scaling part, right? But remember one thing, PG bouncer is thread again, and PG pool is process based. So you may want to really look at testing both, and if it's just connection pooling, you may even want to go with PG bouncer, but it's all after testing. Yeah.
Thank you. We're getting close to the top of the hour. I'm going to squeeze in one more question, and then I'm going to keep track of everybody's questions that we weren't able to answer today. So our final question is there anything like Galera for Postgres?
Again, like Galera for Postgres, yeah, there are some projects that are available that you want to look at, maybe Postgres XCXL, but at this point of time, yes, I would say yes, they are. Even Citus data, right? Even Citus data is available, which is a little similar to Galera-like setup. The answer is yes.
Thank you. Well, that was a quick question. I'll give you something a little bit harder then. How often does the cluster pull each node or slave? Is it tunable for poor performing networks?
Yeah. So, Jobin, would you like to take that question? I know it's customizable, but I would let Jobin talk about that.
So, can you repeat the question once again? It was breaking.
Sure. It was. Where is it?
Like the polling in the Percona cluster, is it customizable? You have poor networks, so can you customize the period as well as the polling?
Polling of the nodes?
Yes.
Well, there is a configuration. So basically, it checks for the TCP layer timeouts. So those things are adjustable. So the configuration, we can say how much time we should wait for timeout to happen. Then yeah, that can trigger a failover. Yes,
Yeah.
customizable. Yeah. And moreover, in the connection routing part, HA proxy also does that. And there also we can specify how frequently it should be tried, the health of the cluster. So HA proxy can, for example, every 2 seconds it can check the status of a node, and if then it can do a further checks. Say, if something wrong, do it in every 100 microseconds, something like that. So every part it is tunable. Yeah.
Okay. Yeah. Thank you, Jobin.
No problem.
Great. Okay. Well, thank you so much, everybody. We are actually at the end of our webinar. I wanted to say thank you. Huge thank you to our presenters today, Jobin, Avi, Fernando. We learned a lot about all of the different things that you can do with Postgres. We hope to see you on future webinars, and definitely check out Percona Live. There'll be more tracks from the Percona team here. And thank you so much for attending today.
Thank you everybody for joining us, and we'll wait for questions from you in the blog post or, yep, thank you.